All right, here we are. It is 12 noon on another Wednesday and time for another KukerRanken Lunch and Learn. Today, we're going to be going through mapping and some basics of mapping with Brady Reisch as mapping applies to us in our industry of construction and survey. So without any further comment, Brady, I'm just going to hand it right straight over to you.
Wonderful. Thank you so much, Douglas. Really appreciate it. And thank you, everybody, for joining us today. As Douglas mentioned, we're going to be talking about an introduction for UAS in mapping. So we're just going to really cover some of the equipment, the hardware, some of the software that might be required, some pretty common terms that we have to understand so that we can be very efficient with assisting with our clients, making sure we get the appropriate deliverables for them. So without much ado, let's go ahead and start here. So my screen should be showing up for everybody. So going over just a little bit, why am I the one kind of presenting this information to you? My name is Brady Reisch. I am the Virtual Design and Construction Reality Capture Specialist for KukerRanken. So it's a very long title. Really just means that I'm the one that's able to integrate a lot of the different drone or terrestrial-based scanning systems into whatever workflow that you would need to have. So I am a 14 CFR Part 107 certified pilot. I've been with a lot of different companies with enterprise support as well. I'm also an instructor for Pix4D and for a lot of SUAS systems. So if you've got any additional questions, make sure to reach out. On the screen, you'll see a little QR code. You can scan that. And later on, towards the end of the webinar, you can also download or go to the link and download my contact information. Makes it a little bit easier for you guys. So with that being said, I'd like to go ahead and talk about this disclaimer here. This is not a complete comprehensive list of every drone and every system that is out there. These are really the solutions that we have in regards to our experience and different things that we would suggest for you as well. So jumping into really the meat of what we're talking about here, as we're using a drone for mapping, we need to understand a couple different terms. So one of those terms is called a point cloud. There's a lot of text here. You don't have to read it, and I promise I'm not going to read it out to you. This is the wiki description. Really what a point cloud is there are hundreds of thousands or even millions of points that are put into 3D space. Each of those points have an XYZ value associated with them, which gives us our 3 dimensions, what things look like they're kind of built up. So if you look at the video on the slide or the little GIF here, you'll see as we're rotating around, there's millions of these points in this aspect, and this is just called a point cloud. So that's going to be our first term. The next thing that we need to understand is there are different types of ways in order to get a point cloud. So the first one being photogrammetry. This is one of the easiest ways to do it as far as budget-wise goes. So with photogrammetry, we're taking images, these still 2-dimensional images, we're stitching them together, and then we're extracting a point cloud out of that in order to get an XYZ value for each of those points. So this is really just saying we're taking a flat image, and because we have so much overlap and things connecting, we're then able to extract that information into 3 dimensions. So that's going to be one of the easiest and one of the most cost-effective ways of getting into generating some sort of a point cloud or a deliverable. So then one of the other ways here is using a LiDAR system, which is light detection and ranging. So this essentially is just a laser that gets sent out. And what happens is there's a timer. So as soon as it gets sent from the sensor down to the ground or touches something, and then it returns back, and then it says, hey, I saw something, let's do it again. So it has different amounts of returns, whether that's 2, 5, or 16 returns. There's different aspects of that, but that's something we'll get into later on with some of our other lunch and learns. But really the basis is that laser getting shot out knows a specific distance that was captured from the sensor, to which we have a giant, I put it into, it's almost like Excel, where the comma separated value, it has an XYZ value, and it just generates that point cloud automatically or very, very rapidly compared to photogrammetry. So LiDAR is very quick, but it's more expensive to get into. Photogrammetry is very inexpensive to get into, but it takes a long time to process. So as we are flying with either LiDAR or photogrammetry, we're flying our drone in a specific pattern or different way to fly the drone. So the first one we'll cover is the grid. So it's just flying back and forth at different levels or different areas in order to capture whatever you need to have mapped. So with this, traditionally photogrammetry requires somewhere between 70 and 80% overlap, while LiDAR, depending on the system you have, could be as low as 20%. So this is where your efficiency really kicks in using that LiDAR system. So grid pattern, you're just moving back and forth. There's also a double grid. So instead of going east and west, now you're going east, west, and then it also comes and crosses over each of those paths, north and south. So you just get extra coverage. So as we're flying these different types of grid missions, there's different camera positions, and this one is specific to photogrammetry. So we have the first one, which is nadir. Nadir just means that the camera is pointed straight down. That's it. 90 degrees is straight down. So we're capturing really good information on the roof, but when you have vertical structures, you don't quite get nearly as much detail that you would need. So the next mission path that we have is called obliques. So we're flying around, usually in a circular pattern, to different angles, so we can get more of the side information on that building. So nadir is straight down. Oblique is anything that's not straight down. So you can put it at 80 or 85 degrees, and I'll give you a tip in just a little bit about that. So now we know some of the basics on some of the terminology and what we're going to be using. We need to first understand what kind of an aircraft are we going to be using. So I've got a couple here that I'd like to point out. The EVO 2 6K Pro is a workhorse, and this is my personal favorite. It's very easy, it's very small, it's modular. It's got a very long flight time of 38 minutes. There's no geofencing in the US whatsoever. In most countries, there's no geofencing unless the government requires it. The cameras are interchangeable. It's got 360-degree obstacle avoidance, and you do have local US support here in the United States, which is certainly very beneficial. So some of the other systems that we also have beyond going with the Autel series or the Autel EVO 2 series is going to be a rather large drone, which is going to be the DJI Matrice 300. So I think everyone here has always heard about DJI and the different types of products that they offer. This is their enterprise level solution. So this is a larger, heavier lift aircraft. It's got an amazing transmission of 15 kilometers. It's got 55 minutes of flight time. It uses 2 batteries at the same time, and they are hot swappable. There are the operating temperature, minus 20 to 50 degrees Celsius, is extremely high. So you can operate in almost any sort of weather condition that Mother Nature throws at you. There are many different types of payloads that you can have. So this can be either a photogrammetry or a LiDAR system. There are different payloads to use speakers, spotlights. So it's very, very modular. It is IP45 rated, and it's just a workhorse. So if you really need something that's enterprise level, this would be a good solution for you. So the next one that I want to talk about, just the one last aircraft, is going to be the microdrone system. And it's not necessarily just the HR payload, but they also have a UHR system, which is really going to allow you to penetrate to the canopy. And we can talk about some of those basics in just a little bit. So with this type of a system, it's all-in-one integration, so it's easy to utilize. There are different types of payloads. Although microdrones does focus on the LiDAR side of it, there are some photogrammetry options if you'd like. This is going to be NATO compliant for governmental use, so there's no Chinese parts whatsoever. It's actually all built in Germany, and then also here in the United States. Let's see here. And you can use multiple different tablets to operate this aircraft. So you can have 3 or 4 different tablets if you'd like to extend your range. And again, it's got a very, very high rating for its operational temperature between negative 10 Celsius and 50 Celsius. So an absolute, it's a large drone. I like to call this one the macro micro. It's actually the smallest one that they currently offer. And this aircraft is really, really amazing for LiDAR systems. So now we've determined what type of a drone we're going to be using, whether it's a small, a slightly larger enterprise, or a very large system for heavy lift. We know what kind of a sensor we have, whether it's photogrammetry or LiDAR. Now we go into, well, how do we actually fly this thing? What's going on? So there's many different types of programs depending on the hardware that you have. So as an example, DJI has what's called DJI Terra. This is DJI's mission planning and processing application. So this application kind of has twofold. Number one, you can operate the drone using a laptop plugged into your controller. So then it's feeding information from the laptop on where to fly, how to fly the grid, make sure you've got your appropriate overlap. But DJI Terra also will process the information into your finalized product. So this is kind of a twofold, where most of these other programs that we're talking about right now is just about how to fly the drone in its specific grid pattern or in its specific mission. So there's Mission Planner. It's one of the oldest planning softwares out there. A lot of Pixhawk and Arduino systems utilize this Mission Planner system. And this, again, is really, they all boil down to the same thing, where it's telling the drone where to go and what to do and how to capture. So you can set up different parameters for overlap, how you want to move to this or to that, when you want to start your capture. If you need to launch and land from the center of your mission area, which is always suggested. So there's your first tip. Otherwise, you can be off to the side and capture because maybe you can't physically walk down to the site. There's lots of different reasons for it, but these mission planners allow you to tell the drone where to go and how to capture that information. There's also a UCCS planner. Again, it's a very long time mission planning tool that's extremely powerful. A lot of these types of systems do lean towards DJI, but there are some applications, and usually each manufacturer will have their own option available to you. Just be aware that some might have extra features where others might not. There's also open source web. Again, leans very heavily towards DJI, but this is something that is open to anybody. There is Lychee, which is very, very popular. And I apologize, it's not DJI only, but it leans very heavily towards DJI. And it's got some very advanced planning routes and waypoints. And it just, a lot of these programs have extra little features that not all the other programs have. So you just have to decide what works best for you, which is why I would always suggest to contact your local KukerRanken representative and give us a shout. We'll talk about what your needs are and figure out what the best solution for you is. Now, there are some systems, such as the microdrone system, which has to use its own proprietary capturing application. So MD Cockpit, for example, and this runs on an Android tablet. It's very easy to use. Again, you can see the white lines on where the aircraft is going to be flying, and the blue shows you where it's going to capture. We've got a couple extra points, and we'll talk about what those are later on when you go through some of the training for the microdrone system. So, a few tips that I'd like to go ahead and mention. Number one is when you're mapping with vertical surfaces and using photogrammetry, you don't have to, but I would highly suggest to change your camera pitch to about 80 to 85 degrees to allow more information to be captured on the side of the building. So if we think about that, with nadir, we're shooting straight down. We get really good capture of the roof. However, we don't get much side information on the building itself. So you have good ground, good roof, but it's kind of missing all the windows and all the walls on the outside. So if we just change our pitch just a little bit, about 5 to 10 degrees forward, we're gathering more of that side information, which allows us to create a better model or a better map. Depending on what type of hardware you have, you must find the efficiency in conjunction with the precision that you need in regards to height and speed. The slower you go, the better data you're going to get, but it's going to take you a lot longer to fly. So you have to find that good efficiency location. Personally, I like to fly between 100 and 200. So we usually average that out to about 150 feet to get the best precision while maintaining our efficiency with photogrammetry aircraft. I would also highly suggest use manual image capture settings. If you are flying during the early morning hours or early evening hours, what could happen is the sun changes over time. Say our map is going to take us 30 minutes to run our mission. Well, over 30 minutes, the light changes a lot. So in some areas, it's going to be very light. In some areas, it's going to be very dark. And when you use the automatic settings, it flickers back and forth on the camera settings. So it could change and could affect your map. So it's just easier and a better methodology to have a manual settings set up so that when you're capturing, it's going to be very uniform across your entire map and your mission area. Now, a few tips for using LiDAR. Fly parallel to vertical surfaces to capture. And again, this is hardware dependent. As an example, the microdrone system shoots lasers to the side and down. So if you're flying parallel to the building, you're going to capture that side information. With the DJI M300, say you have an L1 sensor, which is the DJI's LiDAR system, you would want to fly directly towards or perpendicular to the vertical surfaces. So it really depends on the hardware that you have. Again, the slower you go, you're going to produce a higher density of point cloud. But again, you're going to lower your efficiency. So you must really find that efficiency with the precision in regards to the height and speed. And this is all going to change depending on which hardware you have. The last tip I'm going to give you before I move on real quick is use strobe lights even during the day. So there is a great article that I will have to find towards the end of this webinar that I didn't have a link already prepared for, where my colleague and I, Douglas, went up to a area to capture a downed aircraft. And it's a great article, but we use strobes to help identify which aircraft was which one because we were both flying at the same time. So I would highly suggest using the strobe light even during the day. So when we have that information, we've now flown our mission. Now, how do we get our data, right? How is this processed? So there's a couple different softwares. First one I'm going to talk about is going to be the Pix4D Mapper system. This is a high-quality mapping solution, uses photogrammetry or videogrammetry. It's just videos instead of still images. This will allow you to generate a two-dimensional or three-dimensional deliverable for your client. And many tools for point cloud editing, such as volumetrics or orthomosaics. This can be an online or desktop processing, which is available through the Pix4D Mapper. And this is really going to be a common solution and preferred solution for many beginners and professional mappers. So from the Pix4D line, there's also two more products I'd like to talk about briefly. First one is Pix4D Matic. Sorry for the noise. Someone's closing a door here. The first one is Pix4D Matic. This is going to be very similar to Mapper. Pix4D Matic is a little bit updated. It's got a better user interface. It's got many of the same editing tools. But really where I think that Pix4D Matic shines is it has an enhanced reality capture engine. So when you process the information in all the photogrammetry, you don't get as much blur and what I call the ice cream effect, where things kind of look like they're melted on your model. So it's got a better engine to process that data. Then what the other system I want to bring up, which is primarily for public safety, is going to be Pix4D React. This is extremely fast processing. Again, uses photogrammetry, so stitching the images together. But this system is only for 2D orthomosaics and measurements only. So as we take our images and stitch them together, that's it. It doesn't extract to show a point cloud. So this system does not show a point cloud, but if you just need a flat surface or something very, very rapid, Pix4D React can be very beneficial. I personally use this when I am on any job site for any clients. We will capture the imagery. We'll process through Pix4D React in the field just to make sure we've got appropriate coverage. And then when I get back to the office, we'll then process through either Pix4D Mapper or Pix4D Matic. Then we also have Leica Infinity. So this is a high-quality all-in-one program for GIS and photogrammetry. So it, again, uses all just the images. It's not just for mapping, but a whole suite of geospatial tools and features. This is all localized, so you'll have to have a fairly powerful computer in order to process. And this is excellent for firms who have already utilized the Leica hardware and software within their workflows. And then we have MD Infinity and LP360. So MD Infinity is from Microdrones. LP360 is from GeoQ. And if you haven't heard the announcements earlier this year, Microdrones has acquired GeoQ. So Microdrones is the overall company, and the GeoQ is still its own separate band, but they're flying under the Microdrone banner. So this both of these systems are integrated processing for the Microdrones and the TrueView LiDAR data or sets of data. And this doesn't only mean Microdrones. You can fly photogrammetry, you can fly an Evo, you can fly a Matrice and process through like LP360. So it's kind of a all-in-one program to look at that data. You can look at this online using the MD Infinity or local, and then with LP360, it's local only. It's great for processing information extremely fast to get really densified point clouds and get that deliverable out as quick as possible to your client. Now, with that being said, the last thing here that that I'm going to bring up before we start asking Brady questions is we do have a mapping guide that is available on our website. There is a link that will be posted here in chat in just a moment. And this is the mapping with the Evo 2. This can be utilized with any type of photogrammetry drill. This is not limited to the Evo. However, it's our preferred method. So that is what's called out. But if you have any type of drone, you can utilize it. One last thing I will bring up with the drones is some of the drones have the mapping software, such as the Evo 2 system from Autel. However, the Autel Lite and the Autel Nano systems, although they've got great cameras, don't have the same software on the back end, which means you would have to manually move the aircraft around and try to adjust your overlap and get everything correct before you can process your map together. So they're not ideal for flying mapping missions, just like some of the other Mavic Cine series, for example. That one doesn't have the mapping on the back end software. So yes, you can use any imager, you can use your cell phone, but you don't get a consistent result because that overlap is constantly changing. It's not automated in that aspect. So keep that in mind. So again, what I would highly suggest is get in contact with your local KukerRanken representative. Again, my information is here up on the screen. If you've got any additional questions, let us know, because we really want to make sure that we fit you with the right drone and the right software and the appropriate workflow to get you what you need for your customers.
Outstanding, Brady. We've got a couple of minutes here where folks can ask questions. We've got about 2 minutes that are open. The folks is a good moment to throw any questions Brady's way as we go into our final Lunch and Learn for 2022. We're looking forward to bringing some exciting Lunch and Learns forward in 2023. And I think those have been just put into the, they're put into the chat down there so that you can see what's upcoming and next.
There's a lot of Lunch and Learn, so make sure you're tuning in. It only takes 30 minutes during your lunch hour every Wednesday. So we're happy to give you additional information and anything that's pertinent to what you need. So if there are specific things you'd like to start seeing, make sure to reach out and let us know so that we can get it put on the calendar, because 2023 is filling up very quickly with Lunch and Learns.
Indeed. So on January 4th, that'll be our first Lunch and Learn for 2022. We'll be continuing our very popular series on the Leica 3DR software. Matt Kowalski will be going through 3DR cleaning tools. That's again on January 4th, of course, again at noon, Wednesday at noon. And then on January 11th, we'll be going through RTK and PPK workflows using drones or using uncrewed aircraft. So we've got some good programs that are going up for you. We've got most of our programs filled through about March. But as Brady mentioned, if you've got something that you'd really like to see, you can put that in the chat box down there, and we will absolutely pay attention to it and listen to it. We enjoy bringing you information that we think you'll want to hear. But more than that, we want to hear what you would like us to share with you and present. So folks, this brings our Lunch and Learn to a conclusion. I don't see any questions rolling up through here. So we want to thank you for taking the time to spend with us this afternoon. We know your time is very valuable. Again, a happy New Year and a Merry Christmas. Happy holidays to you and yours. Thank you for a wonderful year here at KukerRanken in 2022. We'll see you next year. Take care, everybody.